certain parts need to absorb carbon to become harder, while others require decarburization to become softer. A charcoal-fired forge creates an environment where carbon naturally flows in and out, allowing the soulsmith to adjust the carbon content of the steel as needed. Tamahagane contains many impurities, and to produce a single sword, approximately 4 kilograms of this steel is required. However, after the forging process, the final sword weighs only about 1 kilogram. Making it unsuitable for heating at excessively high temperatures. When the boric acid melts, it forms a coating on the wielding surface of the steel. Then, when the steel is hammered, the molten boric acid expels impurities, removing the oxide layer and allowing the steel to bond properly. Shaped piece of tamahagane, known as the teko, is fused to a block-shaped base piece. Since the tip of the teko becomes part of the source material, it must also be made from tamahagane. However, as this process is repeated, the teko becomes shorter and needs to be extended regularly. The straw ash and clay have two key roles. They protect the steel from burning by keeping it from direct contact with air. At the same time, they melt into a glass-like layer, acting as a flux to aid the forging process. A key aspect of Japanese soulsmithing is forge welding, bonding of temperature, and hammering techniques, making it a highly skilled craft. Next, we move on to folding forging, one of the most defining processes in Japanese sword making. Unlike steel produced through modern Western manufacturing methods, which is uniform in composition and can be processed by simply extending it, tamahagane contains both hard and soft areas with variations in composition. To correct these inconsistencies, the steel must undergo multiple rounds of folding forging to even out its properties. Process. produced by low-temperature smelting of iron sand and iron ore with charcoal, impurities are not completely removed. As a result, it often contains slag and air bubbles. Western-style swords made from industrial steel can be easily manufactured and provide excellent sharpness. In contrast, a Japanese sword crafted from tamahagane and unrefined steel undergoes folding forging, revealing distinct patterns in the steel and hamon temple line when polished, elevating its value as a work of art. Shingane. Folding forging. The core steel is arranged on the upper and lower sections of the blade. As a result, the sword adopts a dual core structure where the shingane is embedded both internally and externally. Next comes wakashinobe, a process in which the steel is heated to a high temperature while being stretched and extended. This technique is now exclusively used in Japanese sword making. Unlike tamahagane, modern industrial steel cannot withstand such extreme temperatures. It would oxidize from the inside and collapse under the intense heat. Is a stage where the steel is elongated and shaped before the edge is formed. At this stage, the thickness and width of the blade are gradually tapered. By doing in Japanese sword making, minimizing the amount of material removed while the surface of the blade appears smooth due to melting during heating. The internal structure does not fully melt, leaving many impurities. This is because tamahagare naturally contains a high level of impurities. If too much material is removed during polishing, these impurities may become exposed on the surface, affecting the final appearance and quality. Therefore, shaping the blade as accurately as possible during hizukuri is essential. Before quenching, a layer of clay is applied to the blade. This process, known as tsuchioki, prevents the sword from breaking during quenching. At the same time, the quenching process creates the hamon, an important aesthetic feature of the blade. The clay mixture consists of soot, finely crushed whetstone, and shigaraki clay. Though the specific ingredients vary depending on the swordsmith, some swordsmiths even use industrial silica compounds. Vertical lines applied to the blade serve a functional purpose. They prevent cracks during quenching. By applying clay to areas prone to cracking, the construction timing during quenching can be adjusted by fractions of a second, reducing the risk of breakage. This quenching technique is known as stone charcoal before heating and quenching. Since tamahagane contains many impurities, the polishing Due to the nature of the material, whether or not imperfections appear during polishing is partly a matter of luck. While there is some acceptable margin for imperfections, salt making requires significant cost in steel and charcoal. Despite this investment, many salts end up being discarded due to material-related flaws that appear during polishing.